Good morning, everybody. Today, me and my group are going to present a presentation on Industry 4.0 under the guidance of Professor Hamid Afsari. Here, we are going to talk about the Industry 4.0, the four phases of Industrial Revolution. But before we dive into Industry 4.0, let's take a look at how the manufacturing industry has transformed over time. In the late 18th century, Industry 1 began with the introduction of mechanism through water and steam power. This led to the invention of power loom and steam engine, which enabled the transmission from manual to machine-based production. In the late 19th century, Industry 2.0 began with the advent of mass production through electricity, assembly lines, and interchangeable parts. This led to the invention of the light bulb, assembly line, and telegraph, which enabled the creation of large-scale production facilities and the rise of consumer goods. In the 1970s, Industry 3.0 began with the introduction of automation, computers, and electronics in manufacturing. This led to the invention of computer numerical control machines, robots, and programmable logic controls, which enabled the rise of smart factories and the automation of industrial processes. Now let's move on the Industry 4.0. The phases focuses heavily on interconnectivity, real-time data, and AI technology. It encompasses the industrial Internet of Things and smart manufacturing into industrial process to create a smarter, more efficient, and interconnected self-optimizing ecosystem for supply chain management. In Industry 4.0, devices can commute with each other and share data, which enables real-time data collection, processing, and analysis. AI and ML technologies automate decision-making and optimize process, leading to increased efficiency, productivity, and improved quality control and supply chain management. Predictive maintenance and energy efficiency optimizes also reduce costs and waste. The benefits of digitizing the supply chain. What are the benefits? In this slide, we learn about how digitization the supply chain can help companies addresses the evolving needs of customer and improve efficiency. Supply chain 4.0 will be faster with the potential for delivery times of a few hours for high demand products using predictive shipping, where products are shipped before the customer places an order. Real-time planning enables a dynamic response to fluctuations in demand or supply conditions. Customers are now managed in highly specific cluster with the tailored products offered through multiple logistic menus that fit their needs. Performance management system offer complete real-time visibility across the entire supply chain. Automation of physical tasks and planning, such as the use of robots and autonomous trucks, further streamlines product transportation within the network, making it more efficient. Key technologies of Industry 4.0 for supply chain. What are the key technologies? The future of smart manufacturing. Industry 4.0, also known as smart manufacturing, is an emerging paradigm in manufacturing based on IT-driven industrial processes. This new manufacturing revolution is enabled by several key technologies that are driving the digital transformation of supply chain operations. These technologies include big data analytics and cloud computing, industrial Internet of Things, blockchain technology, artificial intelligence, cyber physical system, and digital twin, immersive technology, smart communication, and autonomous robots. With the big data analytics, manufacturers are identify patterns, trends, and performance and preferences that inform better decision making. The industrial Internet of Things is transforming the manufacturing process by enabling machines to connect with other web-enabled devices, facilitating the collections, analysis, and the exchange of valuable data. The other key points we continue here are the artificial intelligence is used to optimize supply chain operations by analyzing data from multiple resources. Cyber physical system and digital twins are virtual reclips of production lines, process, and supply chains that allow manufacturing to test changes to the process or find ways to minimize downtime or improve capacity. Immersive technologies such as AR, VR, MR are creating highly realistic simulations of products and processes that deliver experimental learning and insights. Smart communication among industrial equipment is paramount to innovation in in smart manufacturing with a focus on consistency and reliability. Autonomous robots are smart vehicles are leading to significant operating cost reductions and transformation and product handling while providing benefits regarding lead time lead times and lower environmental cost. These key technologies of Industry 4.0 are transforming the supply chain landscape, enabling companies to optimize their operations, reduce cost, and improve customer satisfaction. Thank you so much. Now, Jasmeet will continue.
Smart logistics is an innovative and efficient approach to logistic operation that utilizes cut-edging technologies. With the help of Industry 4, logistic processes have been greatly enhanced through the use of autonomous logistics, intelligent transportation system, and physical internet, small fleet, and customer-oriented intelligent logistics. One example of how technology can revolutionize logistic operation is Uber Freight, which has disputed the market with its app and platform connecting couriers with the most appropriate shipments available. The use of law-based smart freight transportation is an effective solution to optimize logistic operations. RFID technology is widely used for the identification and tracking of goods and vehicles, providing valuable data for vehicle configuration optimization, path planning, and vehicle routing optimization. The global positioning system and geographic information system are also crucial components of smart logistics, providing real-time location tracking, navigation, and route. Today, I would like to introduce you to the concept of smart delivery. We all know that timely and accurate delivery is crucial for businesses to succeed. However, the current delivery system faces several challenges such as low operational efficiency, delivery failure, cargo theft, and perishable product deterioration. To tackle these challenges, researchers are working on implementing LOT, enabling smart delivery systems by leveraging Internet of Things technologies like RFID, sensor technologies, and embedded systems. We can track and monitor the delivery process, facilitate information sharing among delivery service providers, and ensure safe and accurate delivery of goods. Various smart sensors, RFID tags, and GPS devices are installed on delivery vehicles and connected with servers and other users' smart devices, which ensures the sensing information is communicated and shared. Moreover, the integration of GPS, RFID-based e-seals and mobile network technologies can provide support for vehicle rescheduling in the event of an accident. During delivery, the loss of goods can also be prevented by monitoring the status of the truck with wireless sensor networks. Utilizing sensor data such as vehicle speed and engine speed can help ensure safe driving. Smart delivery not only guarantees reliability and reduces failure, but also enables tracking and visualization of the delivery process and information. It can ensure the safe and accurate delivery of goods while monitoring their delivery status, even for perishable products that require specific environmental conditions. With smart delivery, we can optimize delivery efficiency and improve resource optimization. We can also improve delivery service providers' interaction and facilitate the sharing of delivery information. I believe smart delivery has the potential to revolutionize the delivery industry. In today's fast-paced business environment, efficient warehousing and inventory management have become critical for achieving success. Leveraging IoT technology can help increase productivity, efficiency, and overall service quality while minimizing errors and cost. Smart warehousing involves various activities such as receiving, storage allocation, order picking, and truck loading. IoT technology connects objects with objects and operators in a warehouse, enabling quick response to emergencies and decentralized decision support in a central WMS. Accurate and visual warehouse data can streamline inbound and outbound activities, but storage allocation strategy selection and indoor routing optimization remain challenges. The WMS manages the relocation of goods within the warehouse, supported by the TMS. In today's world of supply chain management, it's essential to manage uncertainties in the supply chain. Demand forecasting plays a crucial part in this aspect. Big data analytics has emerged as an effective tool for enhancing supply chain efficiency and improving the accuracy of customer demand predictions. BDA consists of three types of analytics: descriptive, predictive, and prescriptive. Various techniques are used in demand forecasting, such as time series forecasting, clustering analysis, k-nearest neighbor classification, artificial neural networks, regression analysis, support vector machine, and support vector regression. The supply chain generates high-dimensional data from multiple points, leading to high velocity and large volumes of data. The non-linearity in demand behavior in the supply chain can be addressed with the BDA techniques. BDA is applied in all stages of the supply chain, including procurement, warehousing, logistics, transportation, manufacturing, and sales management. The supply chain generates high-dimensional data from multiple points, leading to a high velocity and large volumes of data. The non-linearity in demand behavior in the supply chain can be addressed with the BDO techniques. It can be applied in all stages of the supply chain, including procurement, warehouse, logistics, transportation, manufacturing, and sales management. The availability of cloud services and high computing analytics has enabled the development of highly accurate demand forecasting models that can learn from data and can be applied at scale in HCM. In conclusion, BDA is a powerful tool that can help companies make informed decisions, reduce costs, and improve supply chain performance. With its ability to handle high volumes of data and nonlinear demand behavior, BDA is a must-have for any supply chain organization looking to stay ahead of.
The digital supply chain has become a critical aspect of modern businesses, transforming how companies manage their supply chain operations. Collaboration and integration among stakeholders are vital for success of digital supply chain, and it often requires big companies to take the lead in integrating their suppliers. By integrating the suppliers and collaborating with them, companies can create a more streamlined and efficient supply chain process. Digital supply chain operates within both physical and virtual supply chain scopes, which are interconnected with various dimensions. These dimensions allow for potential interconnections and configurations in Industry 4.0, creating a framework for businesses to explore new opportunities and technologies. By leveraging the digital supply chain framework, businesses can improve their efficiency and reduce cost while providing better services to their customers. One of the most significant advantages of digital supply chain is the omni-chain concept, which describes how customers can interact with businesses through physical or virtual market space. This concept enables new methods for acquiring goods and services using digital currencies like Bitcoin, which is becoming more popular every day. In addition to payment options, the digital supply chain allows for the collection of real-time information from different channels. This information can be used to create more efficient and effective manufacturing processes, reducing the time needed to manufacture goods and getting them to customers faster. Overall, the digital supply chain is a business process integration that offers end-to-end integration of product data. By collaborating and integrating within this framework, companies can take advantages of new opportunities and technologies in Industry 4.0. Next, on to Baljeet.
Industry 4.0 is an exciting concept that promises to revolutionize operations and supply chain management while aligning with sustainable development goals. However, there are challenges risks that companies must overcome to ensure successful implementation. One of the primary challenges is related to technology. Cybersecurity is a major concern as critical detailed data about individuals can be misused by decision makers or targeted by cyber attacks. Economic challenges are also significant, especially for manufacturing companies located in emerging economies. High costs associated with Industry 4.0 assembly lines and the lack of interest in investing in sustainability due to its long and uncertain payback period are some of the challenges faced by these companies. The use of smart factory can lead to such a problems in local communities as it hinders the opportunity for labor-intensive workforce. Managing human resources to fit into the Industry 4.0 setup is a considerable challenge for top management, and the physical, psychological well-being of workers, aging, and diversity need to be considered. Lack of support from regulatory authorities and the absence of strong IT legislation are major knowledge support challenges. The insufficient technical expertise in Industry 4.0 technology is another significant challenge method mentioned in the literature. Finally, the environment poses challenges as well. The higher production rates associated with Industry 4.0 have resulted in increased resource and energy consumption. In summary, to ensure successful implementation of Industry 4.0, companies must address these challenges for sustainable development goals. Thank you.
I will be discussing some of the future developments and trends in the Industry 4.0 for supply chain. First on the list is automatic sorting and retrieval system, or we can say ASRS. This is a new type of machinery that replaces traditional equipment used for moving some items around a warehouse. The ASRS integrates various functions such as hosting, conveying, picking, and placing items for a more efficient automated process. An excellent example of the ASRS in action is Siemens. They were able to reduce warehouse space by 60% and staffing costs by 40% by implementing this new technology. So, in summary, ASRS is a novel intralogistic machinery that integrates multiple functions for more efficient automation, and it has already proven to be efficient in cost reduction for some companies. In today's fast-paced business environment, sourcing and supplier management have become more critical than ever. That's why sourcing software with market intelligence is a valuable asset for procurement teams. This type of software provides real-time information on potential suppliers and their supplying capabilities, market dynamics, pricing, lead time, and trends in raw materials and regions. By using these softwares, procurement teams can make more informed decisions and stay ahead of the competition. For instance, Molex has partnered with Siemens Supplyframe CQI software for sourcing acceleration. According to IoT Analytics, the sourcing and supplier management software market is expected to grow at CAGR of 10% from 2021 to 2027. IoT track and trace devices are transforming the way companies monitor their supply chain. With these devices, companies can get a nearly real-time perspective of goods within a supply chain. They can track exact location, estimate arrival times, and monitor physical conditions like temperature. Hapag-Lloyd, a German transportation company, plans to connect 1.6 million dry containers with tracking devices by 2023. Over 130 vendors currently offering IoT-based track and trace devices and softwares, making it easier than ever for companies to implement this technology into their operations. Essentially, a supply chain digital twin is a virtual copy of a company's supply chain synced with corresponding data. This technology allows companies to test the impact of real-world changes by simulating and predicting outcomes in digital model. For example, Renault Group recently adopted Google's supply chain digital twin software in September 2021 and replicated 90% of its supply chain flows. By doing so, they were able to make some more informed decisions and optimize their supply chain performance. Overall, this technology can help companies make better experience decisions, reduce cost, and improve supply chain resiliency. Intralogistics robots are transforming the warehouse and logistics industry. Amazon acquisition of Kiva System in 2018 for 0.7 billion allowed the company to achieve next day and second day delivery, which shocked its competitor. Walmart eventually matched Amazon efficiency level a year later in selected countries, but didn't disclose the cost of investment. Intralogistic robots are multi-purpose machines designed for intralogistics picking and placing and can operate in limited floor space. They load and unload parts from shelves, palletizing machines or conveyors automatically, make them highly efficient and controllable in 3 or more axis. The implementation of intralogistic robots result in significant improvement in automation and efficiency, allowing for fast operations and better management of demand peaks. Boston Dynamics Stretch robot is being deployed by DHL in its North American warehouses to increase efficiency and in 2021 49.5k units were shipped, a year growth of 45%. AI-powered inventory optimization software has transformed the way companies manage their inventory planning. This software can process and analyze millions of data points, making the task of inventory planning more efficient. With the help of AI, inventory flows can be automated and controlled, and the software optimizes inventory level based on customer demands. This solution also helps companies identify ways to improve their safety stock levels, reducing working capital and saving money. C3 AI's inventory optimization software helped a Fortune 500 electronic manufacturer reduce its working capital by $42 million. In the APAC region, more than 56% of manufacturers have adopted an AI strategy, surpassing North America and Europe. IoT analysis predicts that the adoption of AI in inventory optimization software will continue to increase in the coming years. Proactive field service software based on IoT technology is transforming traditional field service solutions by focusing on predictive maintenance rather than reactive repairs. This means that instead of waiting for a failure to occur, the software uses data analytics to identify potential issues and dispatches technicians to address the problem before it becomes a bigger issue. Proactive field service operations prevent asset failure and increase asset uptime, leading to early spare part ordering and reducing the need to prioritizing these orders in the supply chain. 3D Systems implemented IoT-based proactive field service software and reduced spare part usage by impressive 62%. In addition, ServiceMax annual customer survey showed that customers using the proactive field software increased their worker productivity by an average of 23%. These statistics demonstrate the significant improvement that can be achieved with proactive field service software based on IoT, resulting in better asset uptime and worker productivity. Supply chain visibility is critical for building resilient supply chain network that can withstand disruptions. Supply chain visibility software helps companies answer important questions like when their shipment will arrive and identify backup supplier to prevent production shutdowns. The software provides a clear and concise overview of critical supply chain matrices, including inventory levels and lead times essential for efficient operations. With supply chain visibility software, company can track their shipments in real time, providing them with accurate information on the status and expected delivery times. It also sends notification in case any delay or issue, allowing for a quick resolution.